So one of the most important requirements on the rooftop solution is the rapid shutdown. And this is something requirement that started first in 2014, but in 2014 wasn't applied strictly to module level. But now basically what they did is like define certain boundaries just to make it more restrictive when it comes to requirements of this rapid shutdown. And basically it's just to reduce the shock hazard which the firefighters are exposed up there. Once they have to get into the roof, they're going to be walking among DC voltage, AC voltages, you know, so they're exposed to electric hazard. So that's one of the requirements that was meant for them to reduce or try to mitigate as much as possible that risk. There's some exceptions. You can see here ground mount exceptions, like this is a ground mount here. And of course, since the fire department doesn't have to go through that ground mount, or they're not going to be forced to be exposed to that electric hazard, it's not required for that scenario. Something that is also applied for another exceptions, in this case like non-closed detached structures. It could be a carport, like this example here came from Chico USA carport. And this is another exception that the rapid shutdown is not required, because we don't need to have the fire department climbing that carport in order to mitigate any fire. Okay, so now since we were referring to requirements of the rapid shutdown, let's see what it's talk about. So first of all, they want us to define an array boundary. So the term array boundary is a perimeter that it consists of no more than 1 foot from the array in all those directions. So if you can see here, you can see how this one is defined this way. You see that perimeter, that distance that you can see from here to here in all of the direction of this array does not exceed 1 feet. So anything that is inside is considered the array boundary. And what's important, because for the most common scenarios, what the NEC code, the NEC requirement is that everything that is inside that array, it has to have that rapid shutdown requirement, and once it is initiated, it has to be no more than 80 volts within 30 seconds. It means like I need to have an activation method to initiate that rapid shutdown, and once I do it, usually it's the PV AC disconnects. I'm saying usually in a grid tied system, no batteries, and once you activate that AC disconnect, it will trigger the rapid shutdown. And what's going to happen, that everything that is inside that boundary will not exceed 80 volts, and everything outside that boundary cannot exceed 30 volts. So that's are gonna be my requirements. You know, if we want to write it down here, everything inside cannot be beyond 80 volts, and anything outside cannot be beyond 30 volts DC, you see, or AC as well, and that applies also for microinverters. That's why I said like DC and AC. Okay, so before we jump to that, like what they mentioned there is like, okay, anything inside the array boundary shall comply with one of the following. So the first one, I'm not going to cover it. This is something practically new, even though it was implemented in the cycle of 2020. But many jurisdictions here in the United States are right now, and they're always 3 years behind any code cycle. So basically what it means is like, hey, as long as it's within that array boundary, or that array boundary defined by the listing, it can be greater than 80 volts, but anything outside cannot. So this is one way to also mitigate electric hazard, because once the fire department is on the roof, at least they know that, hey, the system is a PV hazard control. It means that, hey, we don't deal with anything on the solar panels or anything closer to the solar panels because we know that that voltage is greater than 80 volts, and basically also helps to reduce the amount of electronics that you're going to need to have on the roof, because once you start installing solar panels on a roof of a house, now you need to comply with rapid shutdowns. It means you need to install a rapid shutdown devices on the roof. So more electronics on the roof in this harsh environment, it means that the rate of failure is going to be greater. So that's what the PV hazard control is. It's just like limit the amount of electronics that I can install on the roof, as long as I can follow what the manufacturer requirements are. And if you want to know a little bit more, you're always free to reach out to me or talk to Google about it. So now let's talk about the most common requirements, which is what we have here, which is what we explained. Everything that is inside that boundary cannot exceed the 80 volts, and anything outside cannot exceed 30 volts. So what's the practical part of it? Let's say that I'm going to have these solar panels, right? These solar panels, the VMP, I'm going to call it 35 volts DC. And the V open circuit, I'm going to say is 38 volts DC. So now, since these requirements are practically all, many manufacturers have come with different types of rapid shutdowns. There's rapid shutdowns that they have a ratio of 2 to 1. It means like I can have one rapid shutdown and connect 2 panels to it. There's another that allows to connect 2 panels in series. And basically, depends on the scenario, we choose how we're going to install them. So let's say that I have these sections here, right? And I'm deciding to install a rapid shutdown that's allowing me to have 2 panels per each one of them, right? So if I do something like that, if I install my rapid shutdown here, so I install this panel here and this panel here, I'm not connecting them in series. Then I have another rapid shutdown here, and I do the same with these ones. But now, okay, what's going to happen here? If I want to use this same rapid shutdown, can I connect these 2 panels together, like this one and this one? And sadly, we cannot do it. Why? Because the distance between these 2 panels exceeds the array boundary of 1 foot. And the voltage, at least the maximum voltage that I can get from one panel, is 38 volts DC. A little bit more depends on the temperature correction, but that's the main idea. So I cannot connect this panel, both of those panels, into one rapid shutdown. So I have to, if I want to do it like that way, I have to connect one here, and then I gotta buy another one and connect it individually. Because then again, I cannot jump from one side to another because the voltage exceeds the requirements that our system, our rapid shutdown says. So that's one of the things to consider. So okay, then later you can just connect here another one. Then you got this one here, and then you gotta connect another one here, and you do the same. And then this one is alone, so you will have to connect one of it. And now let's say that my inverter is connected here. So what you do is just connect the strings together, you know, like now the strings of rapid shutdown, this one with this one, and then you go to your inverter. Of course, this is just for the sake of understanding the requirements of rapid shutdown. Okay, and it happens the same with microinverters as well. You know, with microinverters, you have to install microinverters, and if you want to install those microinverters that allow 2 panels per microinverter, you also have to consider that. Because in many scenarios, and in my experience, happens the same. Like they design it in a way, they send the material to the site, and then you just figure it out. It's like, oh, you know what? I cannot do a jump from for example, I cannot go and jump and connect these 2 panels to a microinverter, because if it's gonna exceed the array boundary of 1 foot, you know. So it means like you need to send me another microinverter just for doing and individually have of those 2 panels and those are considerations that they need to be, because now we're talking about wasting time, wasting material, delaying the project. So those are considerations, like little tips and tricks that I can give you when it comes to rapid shutdown scenarios.